This morning I checked the weather forecast to see if I needed to bring a jacket or not, but I didn't need to because it's a lovely day here at Hazelrig Weather Station near Lancaster. One thing I didn't check though is the space weather. I'm about to meet Michael, who's going to explain to me what space weather is and how worried I should be. Hi, I'm Esme, nice to meet you.
Hello, I'm Michael.
So what are we doing here today? Can you tell us a little bit more about this site?
Yeah, we're at the Hazelrig Weather Station. It's a Met Office field site, and for over the last 45 years it's been collecting data relating to our weather here on Earth.
What actually is space weather?
So the sun is always spewing out material into space known as the solar wind. This is a stream of electromagnetic radiation and charged particles which travels towards Earth at 1,000,000 miles an hour. As a result, a short-haul flight gives you the same dose of radiation as a dental X-ray, and a long-haul flight more akin to a chest X-ray.
That sounds quite extreme. So what are the potential implications from this extreme space weather coming from the sun? Should we be worried?
Most of the time here on Earth, it's absorbed by the Earth's atmosphere or deflected by the Earth's magnetic field. But at its worst, it can harm astronauts, damage satellites and unprotected electronics, and cause power grids to fail. Even scarier, space weather once caused a passenger plane to nosedive, and it's even been attributed to some planes disappearing altogether. What's happening here is solar radiation passes through the electronics on board the aircraft, causing data corruption, essentially changing ones to zeros and zeros to ones. Another example is space weather causing a voting machine in Belgium to register an extra 4,096 votes for one candidate. Extreme space weather causes fluctuations in the Earth's magnetic field. This is known as a geomagnetic storm. The Earth is covered in millions of miles of wire carrying electricity. When these are subjected to fluctuations in the Earth's magnetic field, a current is induced. The current can cause the grid to overload, shut down and even fail. Here we have a coil of wire representing the millions of miles of wire that surround the Earth's surface. And here we have a magnet representing the Earth's magnetic field. When there's no geomagnetic storm, no current is induced. Everything's fine. During a geomagnetic storm, when there's disturbances in the Earth's magnetic field, currents are induced in the coil of wire, which can be detected on this galvanometer.
This sounds like a really serious problem. How do we know when and where on Earth is affected?
Space weather events have been monitored by ground-based instruments since the 1940s. There have been over 70 ground-level enhancement events, ranging from the barely detectable to the very strong ones. Leeds in Yorkshire holds the current record. On the 23rd of February 1956, their instrument detected an elevation of over 4,500% in background radiation. Unfortunately, that equipment no longer exists.
I see. So are we at more risk nowadays?
The only difference between the 1950s and even the 80s is our reliance on technology. Space weather has remained fairly constant over the decades, but we're making ourselves more and more vulnerable year on year.
So how do we protect ourselves from this? Because I assume we can't stop space weather from happening.
We can't stop space weather from happening, but if we understand it better and we're able to monitor it better, we can prepare vulnerable sectors and help manage space weather events safely. There are less than 50 monitors worldwide. None of these are in the UK. They rely on technology that dates back to the 1960s, and the detectors are either highly toxic or made of material which is no longer viable, too expensive.
So what you're saying is that even though space weather is becoming more of a problem because of our dependence on technology, quite ironically, we don't have the technology here in the UK to monitor it anyway.
Basically, yes. But researchers at Lancaster University, supported by the UK Atomic Energy Authority and UK SMEs, are developing a new type of cosmic radiation neutron monitor that's cheaper, more compact, and yet capable of producing comparable results to the existing network. It's our hope that data streamed from these monitors will feed into the Met Office Space Weather Operations Centre, enabling the UK to be able to better prepare and predict space weather events.
In theory then, does that mean that when I check the weather to see if it's going to be raining on my commute, that there could be a space weather warning which might inform me of any potential disruptions?
Maybe not quite, but it'd certainly be used by engineers maintaining the national grid, aviation operators, satellite operators, and even railway operators.
Great, well thank you so much for meeting me, Michael, and here's hoping we can monitor any future events inbound to the UK.